Hello, and welcome back. Last time we covered making complex conditions that can do things like trigger effects or block movement. This time we're going to work on the flow of the game. If you're new here, this is possibly the wrong place to start. I will make sure there's a link to the full playlist, but we're basically making a Pokemon battle system with all the fixins, and you're invited. Happy Thanksgiving. The link will be somewhere in the description. Basically, we want to update the battle flow that we have that is kind of bad to do something a little bit more like Pokemon Gen 1, and that's on each round, both monsters choose a move. Then we test the monster's speed against each other, and the fastest one goes first. Then we execute those moves in order, and then we start the cycle again until someone runs out of monsters, or life, or whatever. We'll also handle priority moves, so if someone chooses quick attack, then that one goes before someone who does not choose a quick attack like move. And we're also going to figure out the win-loss states. So yeah, that's basically what's going to go on. This is going to be the last bit of work that we need to get done before we get into adding animations, sound effects, and other cool asynchronous toppings. So let's get started. We're coming up to a point where our game loop is going to become much more complicated, and we're basically going to have to add phases or states to our game loop to express things like we're waiting for the player to choose an option, or we're showing animations, or it's a game over. For this kind of behavior, we can implement something like a finite state machine. Finite state machines sound scary, but they're actually fairly simple once you understand them. Let me give you a simple example. Imagine a life simulation game where your character has an energy level and maybe there's a clock too. The character has two states, awake and asleep. If the character is awake and her energy level is below 20% and it's after 10 o'clock, she'll go to sleep. If she's asleep and it's 7 o'clock, she'll wake up. Basically, a finite state machine is a simple computing model defined by a limited set of states, in this case asleep and awake, an initial state, and rules for when to transition between them. They're not a function you can call or a node you can drop in, but rather a computation model that can be used like a design pattern for many things. If you've worked with animation trees in Godot or Unity, this should sound a bit familiar because you've already used a finite state machine. They're used to set up transitions between different animation states based on variables you set. Finite state machines can also be used for simple AI implementations, like the example I just used. We're going to implement a finite state machine to add a little more power to our game loop. Once we add animations, which we'll do next video, it can look something like this. We'll have 4 states: await input, where we're awaiting input from the player and also processing the AI to choose a move for the opponent. We'll have a resolve state, which quickly runs all calculations for how the moves work out. Then we'll run all the animations to just show the player how the moves are working out. Then we'll either go back to await input if the game is still running, or we'll hit game over if one of the players has run out of monsters. All of this logic will take place within our process function, where we can do something like this. Remember, process runs every frame, so we should not put very computation-heavy tasks in here, but rather focus on checking if conditions have been fulfilled and triggering asynchronous processes elsewhere. So I've got some pseudocode here that you don't have to fully understand. Just understand that this is the process loop that we are going to match on current state. This is like a switch statement in any other language. And then we check the state, and based on what state it is, we do some actions. But the very important thing is that we update the state based on if conditions are met so we can move to the next state. Anyways, this here implements an await input where we figure out enemy move. We wait until the player selects a move, and then if both of those moves are selected, we can move to resolve. Resolve is the most computation intensive one, where we just run all of the math and stuff for the moves. Again, this is not going to be crazy intensive just because this is a simple game, but in a more complex game, you could do this asynchronously. In the play animations state, we are going to run our animations. This we will not handle until the next video. And then in the game over state, which we'll manage at the end of this video, we block interaction until the player either restarts or quits the game. Remember that we have a current state variable that's accessible outside of this loop, so we can use it to do things like block menu access when we're not in await input mode or whatever. Also, although we're doing things based on what state we are in, that logic isn't really part of the FSM unless it's for checking for transitions. Hopefully you can see how this sort of model can be adapted to handle complex processes in many game situations. So let's now fix up our turns. Okay, so at this point we want to work on handling our turn order better. So let's pop back into the script for Game Runner so we can understand what's going on. I think we can still use on turn begun, but we probably need to structure this a bit differently. We want it to work like, as I said before, at the beginning of the round, both players choose their moves, and then we resolve the round. I'm going to create a new enum called phase to handle this. It'll have two values to start: await input, which is going to be the phase or the state while we are awaiting for player input, and run, which will be the phase in which we resolve all of the input. Now, it should only take a single frame to finish the entire run state and move on, but that's going to change very soon when we start adding animations and stuff. Let's add a variable here for current phase, which is just going to be a phase. And this is essentially a state machine now, which can keep track of where we are. Now in process, what we want to do is this. We'll check if the current phase is await input. Well, what do we want to do here? We want to make sure that both the player and the AI both submit a move. So let's have a look at the AI right now. We're going to have to change this significantly, but basically it just has to choose a move, so we can use most of it again. Let's add some ephemeral state here to represent what move everyone has chosen. I think these are going to have to move a little bit later, but we're going to put them in Game Runner for now. I'll call it maybe chosen player move, chosen player monster move, and chosen enemy monster move. They're both typed as moves. Now back in, well, our process here where we are running await input, let's do something with this AI turn here. So we'll check if chosen enemy monster move is null, meaning that it hasn't been chosen yet. We will try to do the run AI turn thing. And what's going to happen here? Well, let's rename this. I think we want it not to run the AI turn, but just to choose the move we want to use. Godot does not have good inbuilt refactoring tools. I always forget. So we're just going to have to type out choose AI move, and it yields a move. Okay, cool. That's great. And then what we want to do here is make sure that, well, let's see. This is going to be a problem because we don't have a struggle move. We don't have a move to use that is default when the monster doesn't have another move to use. So let's make a move called struggle here. And I'm just going to copy and paste smack to do that. Give it, well, we don't really have a unlimited usages option, so I'm just going to give it a lot. It would be easy enough to have a Boolean that set something to have infinite usages, but it's hard to represent that with an integer. Anyways, let's just give it some basic stats, including some self damage, and that should be fine. I'll give it okay accuracy. Great. So now what do we do with this? We do need to have a struggle move to make this work, or else we'll have an infinite loop when a monster can't choose its move. I'm going to add a default move or a default fallback move up in our game runner here, and maybe we'll just preload this resource. And I realize now that this is actually a bad idea because it's a resource. It isn't a move. It's a move resource. If you recall the difference that I probably went over in very annoying detail in the first couple videos of this. So I'm starting to think here that this is not actually tenable and we're going to have to go in a different direction. So to start off though, I'm just going to get rid of some of this stuff. We're going to have to add that somewhere else, but basically we want to either return the fallback move or return a real move. And of course, we can't return the default fallback move because default fallback move is not a move. Default fallback move is a move resource. So what do we do? Well, we could make a ad hoc move here, and I'm starting to smell a problem, and that's that this really does not belong on the game runner. So let's move it somewhere more sensible. I'm going to look up the monster controller here. Well, let's look here. Well, I'm going to add fallback move to the monster, actually. Each monster will have its own fallback move that it stores for itself. And then when we create a monster, we can give it the default fallback move, which will be, well, we can preload the resource, but that's not really the fallback move. We have to actually, well, what? We'll put it here. We will move the preload somewhere else, but we need to make a move new, and then we'll have the move or monster.fallbackMove.resource will equal this preload. So that should work just fine, hopefully. And don't forget to set your move usages here. It should be, I guess, infinite somehow, but I'm just going to set it very high here. Again, we could think of a better way to do this so that it is just infinite, but I'm not going to bother with that right now because it's a bit picky and it won't come up, at least in this prototype. You may have to change this if you plan on releasing this code, which you are allowed to do. You just have to send me a Christmas card or something. Cool. All right, so back in Game Runner, we have our process here. We were trying to run AI turn, which we changed the name of to choose AI move. Let's change that up. We now have choose AI move here. And okay, so if the enemy monster move is null, we run choose AI move. That will either get something from their move pool or get their fallback move, which we have set up now. Now what? Okay, so next thing to do is we will check if the player monster move is not null. Now, if the player monster move is not null, it means that the user has selected a move. We haven't set that up yet, but that's the idea. And then if that's the case, we need to set it to be phase. And I'm going to change run to resolve round just to be a little more clear. Current phase will be phase.resolve round. And so that way our state machine here moves to the next mode in which it's going to resolve all of the moves for us. Now let's check the next state in our state machine, resolve round. So this should only happen if both of the monsters have selected moves. And then we need to make sure when we do this that we go back to the state before and remove the moves so they can choose new ones. So what do we want to do here? Maybe we make a resolve round function that always just runs. It'll take a single frame in this case. Later on, and by this I mean in the next video, we're going to introduce asynchronous animations and sound effects, which will make these a lot more interesting. But basically, there's a lot of rounds in await input. Then when you choose inputs, we run a resolve round in one frame, and we're back in await input. Cool. And then let's do an else here. If there is nothing going on, we can return. I'm not sure if that's super useful actually, but I did type it out, so I'm sure it's important. Okay, so let's make a function for resolve round here. It'll be a void function. Something's wrong with choose AI move. And what is it? Oh, it's not returning a value from every code path because it thinks it's going to get a move. And that's because we haven't hooked up our default yet. So let's quickly do that. Sorry for the disarray this is in. So I'm just going to emit something here, no moves using default. We'll return the monster's default move, which we now have hooked up. I'm just going to add another function here for a get monster move at index. This is going to, instead of use the move, it's just going to return the move, and then we can use the move separately. We'll have use monster move become something that takes in a move and just uses it. So that will be good. This is good for kind of separating our code into much more simple grokkable portions here. So we'll just return monster moves index, and then for use monster move at index, well, let's just change it to use monster move and pass in the move itself rather than the index. And I think this will be a little better with how we want to access moves in our new resolve function. Great, we just have to remove the first line there and it should work just fine. And we want this too because the default moves don't really have an index right now. And we could set it to be like -1 or 5 or something, but Great, so we're going to change this to monster controller.get monster move at index, and we're going to return that. And then we're going to change this one here to be return. We can do the game state opponent monster, I suppose, default move. Fallback move, sorry. Okay, so choose AI move. I think that probably works again. So that's great. So now the chosen move is in our variables, and we can put this on the model if we wanted to, but since it resolves so quickly, we can probably just leave this ephemeral state on the controller. Anyways, back in resolve round, let's do a print to see what's happening. I'll just print each monster's chosen move and see what happens. And it might blow up, so let's see what happens if, okay, yeah, that's bad. That's not great. What's going on? We need to change that to monster controller.get monster move at index rather than just use, because that's not a function anymore. And we need to make sure we set the chosen monster player move to that also. Okay, cool. So that's the handle request menu item by index in interaction mode. Okay, cool. So that looks great. Now it's just spitting out the 2 ref counted numbers for our 2 chosen moves. So everything is working, as far as we know, just fine. And I'm just going to, after current phase here, after resolve round, we want to make sure we reset it to await input, or else we'll get an infinite loop. So let's change it back to current phase await input. This isn't going to finish fixing that because we also have to set our 2 move variables to be null, or else it will immediately go back and change the phase into resolve round. So let's make sure we null those 2 pieces of state out. Okay, let's make sure that that works. We should just get only 2 mentions of the ref counted moves, and it does that, so it's working perfectly. Okay, so now both monsters are choosing a move. Okay, this is great. So back in resolve round, we can remove our 2 print statements, and now we just want to use the monster moves. So we'll do monster controller.use monster move. And what do? Well, we'll use the chosen enemy monster move and chosen player monster move. Now, all we got to do before this is do a speed test, but that should be very simple, right? And we also have to pass in a monster for use monster move, of course, right? So, yeah. Okay, so that should essentially run around now. I'm going to play it to see, and then we can work on the speed test. I mean, I think you could probably figure out the speed test yourself. It's not going to be very complicated. Okay, it seems like our thing works again, so that's something. Okay, so let's have a quick look here. In game state, we have an isPlayerTurn variable, and we are going to get rid of that because it's not going to be used anymore. We don't actually have a concept of it being player turn or enemy turn. It's just the whichever monster is faster is just going to go first. And then we also have get current monster here, which is only used in on turn begun, and that relies on it having a discrete turn. So we're going to have to find a new way to trigger on turn begun, because that's what triggers our condition effects. So for now, let's just get rid of isPlayerTurn, and we'll have to put a pin in the idea of giving on turn begun somewhere else to be triggered. On turn ended here also does some stuff with player turn and on turn begun. I think we just get rid of this for now. I'm just going to look for the usages of on turn ended here, and they're used after moves, so I think we can just get rid of them here. Yeah. Oops. Yeah, gonna kill this. Perfect. Okay, we just need to find a new place to call on turn begun from. And this kind of architectural rejigging is something we do all the time. And is player turn used anywhere else? It's used on this kind of fake speed test here that we that's how we're assigning it. So let's just get rid of this because we don't care anymore. Perfect. We put that same code in resolve round to do our new speed test. So let's make a new variable here for player goes first, and it's that. Again, like this will just resolve into a true false variable. Something is wrong. Oh, we forgot. We're missing monster speed. Okay, great. Now we can check this variable and execute moves in a different order based on it. So cool. Go if player goes first, we can run them in one order, and otherwise we can run them in the other order. There's probably a cooler way to do this, like, I don't know, putting them in an array and sorting them based on something, but with just 2 items, I don't think that that's important. Anyways, I had to swap the order of them, but that's okay. And then we'll drop it down here, and then we'll swap the order again so that the player goes first, or enemy goes first. Okay, I think that's the speed test we need, more or less. And now this won't be super clear because we're not animating anything yet, but we'll be able to see the output in the log on the side. So let's play. And we'll see if it breaks. Well, okay, knife dance. Salamander, I think, is faster than Reggie, so he should always go first. But what if he wasn't? Let's try that out. just to make sure that our logic is working. What if Salamander had base speed of 1? Reggie, I think, is 2. If we play, if we fight, and if we knife dance or whatever, Reggie goes first. So that is correct. We can now affect the turn order based on speed. Perfect. All right, killer. So now we've got a function we need to make, I think, called do monster turn. And that's going to, I think, handle the move and also probably do the on begun turn that we had scared away. And since it starts with monster, or has the word monster in it, it probably belongs in monster controller. So let's put it in monster controller. So in monster controller, we're adding do monster turn, and we're going to give it the monster. And what does it do? Well, it's just going to do the monster turn. I'm returning for now, just so we can have a quick look at what we need to do. Basically, I think we want to use monster move. We don't need the monster controller global there because we'll be inside monster controller, which is a very good sign that you need to move it somewhere. And then we see that, oh, we need some ephemeral state from what? The game controller? Okay, so something's weird. I think chosen move needs to live on the monster itself. That makes more sense to me, even if it is ephemeral. I'll put it here with move block because that's another piece of state that is ephemeral and will get cleared quick enough that we don't need to worry about saving it, I don't think. Okay, cool. And here we are. Player goes first, else enemy goes first. What do we want to do with this? Well, now we have to move our chosen moves out of this and put it into the monsters themselves. So that should be pretty easy, but we'll need a little bit of work here, but no problem. So let's change this to game state dot, what is it? Opponent monster dot chosen move is null. Then we will set it. And then if chosen monster move isn't null, we'll have to make sure it's player monster though. We can continue the round, and then at this point we can flush them. Though, really, I think that belongs somewhere else. Let's go back to monster controller. I think that belongs in do monster turn because we have the monster there already, and we might as well. Perfect. Okay, so now we've got that. We have chosen player monster move, which should be changed to game state.player monster dot game state.player monster dot chosen move. Beautiful. And let's go back to game runner here. And now we've got a problem here because chosen player monster move isn't a thing anymore. What do we want? Let's change that to be game state.player monster. And that's the selection from the menu. Excellent. And then we've got a bunch of problems here, and that's just going to be resolved by a little bit of elbow grease. Change those all to the correct functions. And then let's deal with on turn begun, because now we do have somewhere we can call it. We can just call it in the do monster turn thing. And look at this. Whose turn is beginning? It's a monster, so this should also go in monster controller. I'm dropping it there, and if you notice, now we can get rid of a bunch of these global import names, which again is a sign that this belongs here in this class, we do not need to complicate it by putting it somewhere else. Great. And then instead of looking for a current monster, we'll just pass the monster whose turn we want to begin in, and then we'll do on turn begun, and then we'll pass in the monster. And that should work again. That should give us everything we need. Okay, let's clear out these errors here. I don't think any of them are pertinent anymore. And I'm sure I missed something, but let's play and find out. If I do knife dance, we get invalid access to key usages on a base object of type nil. Uh-oh. Okay, what's going on? So that's in use monster move, we think. Going back to game runner here. Let's see. There's no move being passed to monster move because monster has no chosen move. The move is not being passed to use monster move. Why? Okay, I see we're accessing it through GameState.PlayerMonster, and we actually need to access it through just monster because we have monster here. So that should improve things. Okay, let's give this a crack here. Hopefully that just resolves our problem. We press play, we look, we hit fight, and we hit our debugging breakpoint. Doesn't matter, fight. Okay, and it looks like things are running again. I don't see an error, so excellent. I think we're now in a state that's a lot closer to the Pokemon flow. So let's move on to a couple of other things. The first one I want to do, which is an easy one, is to implement fast moves like quick attack or swift. We want to add a move priority option that overrides the speed test. So let's go to our move resource and we can add that here. I'm just going to add another variable export for move priority, and we could make this be a Boolean, so like some moves are fast and some aren't, or we could just give it like an integer and then we can compare integers. So maybe if you want even more expressiveness, some moves are super fast, some moves are very slow, you could use that. Again, this is a design decision that you can make. I don't really care, but an integer is fine. A Boolean would just save a few bytes. So I'll do that for now. That's my choice. Let's create a new move resource to try to use this. So I'm gonna make fast attack. This is how when you attack by not eating very much for a long time. I'll call it fast attack. Well, and we'll give it some damage or whatever. Just going to make this a bit wider because it's hard to see. We'll do 10 damage and it will have only on hit. Great. And move priority, we'll just make it 1. And we will test move priority against the other move's move priority. And if that move's move priority is higher, we'll just go first and we will not bother doing the speed test. Otherwise, if both moves have the same move priority, we will do the speed test. Cool. So how do we express that? Well, let's see. Because this is going to be a bit wild, let's introduce a new utility function. Does player go first? And we can use that to compare the two monsters and return a Boolean. This is a good way to keep your code more readable rather than having these long lines of stuff. Just make a new function that says exactly what some code is going to do and then use it. So yeah, let's do that. We will pass in 2 monsters here. We'll call it player monster or opponent monster, which can be a monster. Now, since the monsters are already carrying their ephemeral chosen move state, we can refer to that here. We don't have to pass in anything else. Okay, let's do some ifing here. The conditional logic for this is a little wacky, but it should be clear enough. So we'll just check if the chosen move of the player monster is chosen move resource priority. That looks like we need a getter. This is too much of a nasty long access. So let's just quickly add that to move. We'll add get priority. Again, I think this is optional. I just think it does improve stuff, just readability, by not making you read as much. Anyways, we can do chosen move dot priority now is greater than, and don't do greater or equals to, because we want to do something else for equals. Do greater than opponent dot monster dot chosen move dot priority. In this case, the player is using quick attack and the opponent is not. Let's add another if up here. We'll do if player monster chosen move is null or opponent monster move is null. This is a case where they don't have moves chosen. And actually, this is kind of an error case, so we might want to do something like an assert here. Asserts can be tossed in when you get to exceptional behavior that you want to break on or whatever, or want to put out an error message. So we're going to just assert that both of these things do not equal null. And if they do, we'll get a message about it. Okay, now we know that both aren't null. Good. Now, player monster move chosen move dot priority is greater. That's fine. If this is the case, we want to return true. We return yes, the player does go first. Now we want to check if the opposite is true. But again, don't use the equals to, because we want to do a speed check if that's the case, which will be often the case. So you can copy and paste that however you want. We'll return false, which means it's not players going first. And then if both are equal, which is the else state there, we can return the speed test here. Okay. Make sure you return that, me. Very good. Okay, now we just need to use this. So let's var player goes first. Well, what do? We can just ask, does player go first? And what do we give it? Player monster and opponent monster. Okay, cool. Now, let's test out our fast attack. One quick note is we are giving preferential treatment to the player monster here. In Pokemon, they flip a coin, do a 50-50 chance if the two monsters have a speed tie, I think. Well, you can add that if you want. I'm not going to bother, but it's easy enough to do that. And we can check, does player go first, and test it now in our game by adding a move priority to something, messing with our speeds, and just see if everything works properly. So Salamander has very low speed, and if we run it, if we give him fast attack, something's missing here. Okay, yeah. It's named wrong. But if we use that and we are accessing the wrong priority again, it actually is supposed to be called move_priority. So I'll just fix that. Good. And I'll just rename that too, just to make things consistent. Okay, now we'll change everything back to, say, move priority, which may be a little redundant, but clarity is good. And now we should be able to test this. Okay, remember Salamander's got really low speed right now. So if he uses his knife dance, he should go after. But if he uses his fast attack, he should go first. And that looks like it's working just fine, and we die. So that is working fine. The next thing we want to handle then is critical hits. So I believe in Pokemon, critical hits are based on monster speed. So we can also use speed here to try to, roll a random here to see if the monster should be critting or just normal hitting. So I'll make a variable for crit here in our do move code. And we'll make it roll on the same RNG service, a random float. And what do we want to roll under here? I don't know how we should implement this in the end, but I'll do something simple here. We could just, see if it's less than the monster speed divided by 100. So if you have 100 speed, you have a 100% crit chance. That doesn't seem great. We'll probably want to clamp that somehow. But that's one way you can do it. Again, I don't want to twiddle too much with this math because that's really stuff that's based on your own design in your game. But yeah, we can do something a bit better than this, I think. So I'm going to add a new script in utils called calculations. I think we can use this to hold any interesting calculations, and I think we want something more complicated here. So let's do that. So we'll just we'll make a hopeful function here called calculations.getCritChance, and we will add that here. This is going to be a static function in calculations. So static func get crit chance. And we will pass in a monster, which is a monster. And we have to return a float, which is going to be a number between probably 0 and 1 for the percent chance, 0 being 0% and 1 being 100%. I want to clamp this, I think, because then we can make sure that it is between some minimum and maximum. And I'm thinking that there should always be between a 1% and 50% crit chance. Again, these numbers are arbitrary, and you should choose the one you want for your game, or even change this whole function. But this is what we can do. And then the value we're going to be clamping, we can do the monster speed divided by 100 as a thought. Make sure that's a float 100, because then it won't, then it will do float math rather than just make it 0 or 1 essentially, or some other integer, but probably something like that, probably 0. And then I'm thinking maybe we want to have it so the difference between the two monsters' speeds matters. So I'm thinking, well, we could do the monster speed minus the other monster's speed and then divide that by 100. This way, if the other monster's very slow, you might critical hit them more often. But if they're very fast, you'll have the minimum chance. And I'm just going to add a plus 20 offset here just so that there is a higher chance slightly. And like the other monster's speed isn't going to have as much effect. Anyways, play with these numbers. I don't know if this is great or not, but it will work. Great. So I like having my calculations in some small static functions in classes like this. That way we can get to them wherever we want, and they're very easy to unit test if we want to do that, which I'm not going to cover in this series, but it is a handy thing to do when you're doing those mathy things, so you know you're getting the right values. Okay, so we'll do crit, RNG randf, and it's going to be calculations.getCritChance. and we want to take in the monster, and well, target's a problem, right? Because target is not defined yet, because that's done within each thing. So you know what? I'm just going to simplify this for now. If you want to do the target checking, you can do that also, but I think this will be okay for now. Sorry, that's a bit disappointing. Anyways, we'll just do that. It'll still give us a random range, and if you want to get more complicated, you totally can. You could just grab the target as in the opponent monster and run that, but I'm not going to for this. Anyways, now we have a Boolean representing crit, and if we have that, we can, well, let's log a string at least. We'll say critical hits. And then let's see here. Let's give Salamander a huge speed so he'll get lots of crits. Fight, fast attack, nothing, fast attack, critical hit. Okay, so that's great. It seems like it's happening about 50% of the time, which I think is the expected amount of time. Excellent. Now we want to pass our crit Boolean into our effects. So to do that, what do we want to do? Well, we can go to do here, and I think we need to add another argument that says if something is a critical hit or not. So it's always a little bit of a choice to add another argument to our override functions like this, but I do think this is an important one, so I'm going to add it as a new argument to all of our do functions. And this does mean we are going to have to update every single use effect function, but I think it'll be worth it. Okay, so now we're getting an error, too many arguments for the do call. I'll also do it for should do because we have that filter, right, that can distinguish between hits and misses. We can also have it only do things on crits too, which could be useful if you want to add a condition on a crit, right? Then I'm going to go to where, let's look at our targeted effects in scripts content, and we want to add the new argument to our do and should do. So there'll be a Boolean called is critical. And then we have to make sure we add that same signature or update that signature in every single one of our inheriting classes. So let's do that super quick. If you have been adding your own, this could take a little longer, and this is probably why you want to get your game fully fleshed out before you add all of the content, because changing this midstream is a bit annoying. So I don't think should do is, I don't think should do has been overridden anywhere, so we don't have to worry about that, but do definitely does. Okay, so that probably resolves that error. Okay, and then what do we want to do with this? Well, let's also go back to our targeted effect here and update should do so that it will check also for a crit outcome filter. Again, I don't know what I want to do with this yet, but we definitely could do something where an effect only happens if it is a crit. And crits are always going to be hits also, so yeah. We'll just check here. Or is hit or is crit and outcome filter equals outcome filter dot crit. Now, the way we have set up crits, they will only be checked on a hit, so that's okay. Great. So I'd like to test this. We're going to add a crit function on Knife Dance that does some damage if you crit with it, like 20. And only on crits, so we can see if the outcome filter is working for this. Cool, I will play. Something failed because we are not passing in enough things to the do in our on turn begun. So I'll just put it in false. If you want to make conditions able to crit, you could think of a reason why that would happen, but for now, just false. Then if we fight and Knife Dance, nothing happens. Knife Dance, it's a crit and it does 40 damage. Okay, cool, because it's, I think, a weakness. Perfect. And then the last major thing we got to do here is respect the crit in our damage doing script, because we want, when you do damage and it's a crit, you probably want it to be some number more damage, probably multiplied. So I'm just dropping Salamander's speed down a bit so he doesn't get every crit. And in do damage here, we probably want a new coefficient here. But first I'm going to export a variable for critical hit damage coefficient, and that's just going to be what we multiply the damage by if it's a crit. And then we can do that here. So var crit coefficient, and it's going to equal 1 if not, well, we'll do critical hit damage coefficient if is crit, else 1. And then make sure it's 1 and not 0, because if it's 0, it will make it so only critical hits do damage, which is not great. And then make sure you multiply that into our math there, and that should help us. Okay, cool. Yeah, that math is getting a bit complicated, but really we're just multiplying 4 numbers with each other, and I don't know. I think it should read fairly clearly if you read the variable names. Okay, we should test this out. I'm just going to give Salamander big speed again so that we can test. And we run it. Go fight, and then we'll do our fast attack. It's a crit and it does 15 damage. And then hopefully if we do it again, it'll do 10 on a non-crit. It's a miss. I'm critting a lot. Yeah, there we go. If we don't crit, it's 10 damage, so that's correct. Okay, that's critical hits basically handled. Now on to the next thing. Next thing I want to do is handle the win, loss, and monster fainting flow. So we need to check a monster if their hit points are 0 before they do anything, because they could be knocked out by a move right before they act. So let's do this in adjust monster hit points here. I already have a to-do written here apparently, so that's great. So we'll do if monster hit points equals, well, 0. And remember, we have a clamp there, so they'll never be less than 0. Faint monster, and then we'll put the monster in there. Okay, we need a function for faint monster, so let's add that down here somewhere in the monster controller. Great. So faint monster, we'll take in a monster and return void. So I'll return it for now just to shut up the errors. So what happens when a monster faints? Well, we know it can happen at any point, so we do need to start checking for this whenever like a turn begins or a monster uses its move, right? Because they could faint after they get damage from poison. They could faint on their enemy's turn. They could faint from like backlash from a attack. But I'm going to check on turn begin here first. So if they have 0 hit points, we will fail them out. And then if they have no moves or 0 hit points, we'll also fail them out of use monster move. Okay, cool. All right, so that prevents them from doing anything if they are fainted. That's good. They'll need to swap a monster in at some point. I think also in use monster move, we want to check if the opponent monster has no move. I think we want to check if the opponent monster is fainted, in which case we can also return, because we don't want to use a move on a fainted monster. So we'll just grab the opponent here using the function we already made for that in monster controller, and we'll just check if they're fainted and return if that's the case. Terrific. Okay. So I think if a monster faints at the end of the round, we want to bring out the next monster in the trainer's bag. I know in Pokemon it gives you a UI screen to choose the next monster, but I think I just want to simplify that away. You can add that if you want, it's not that hard. So let's go back to Game Runner, because that's where our round code lives, and then we can check for a feint and start moving some monsters around. Let's do that. In Game Runner here in Resolve Round, this looks like it's probably where we want to do this. We'll check if either monster is fainted. And then if they are, we want to swap to the next one. If they're both fainted also, that's also fine. I think we need a function, and it probably goes in trainer controller, but a function that will get next usable monster. And we'll pass in a trainer for that. Maybe we'll get the index of the next usable monster. So in trainer controller, we're making a func get next monster index, or get next usable monster index. And in here, we want to pass in a trainer, and it should get the first monster that it sees by index that is not fainted. So we'll start with a null here, and then we're going to iterate through the trainer monsters to find one that's not fainted. Let's do that. And we can return a -1, perhaps, if there's no unfainted monster. And that we can use to say that the trainer has lost. And instead of iterating through monsters, let's iterate through the index of the monsters using forIndex in range trainer.monsters.size. This way we actually have the number rather than the monster itself, which is what we actually want to return. So then we want to check if trainer monsters index HP is greater than 0, and if that's the case, we can just return. Well, we don't really need this monster thing at all. We just want the index, which we already have. So we'll just return index, and we'll drop monster at the top there because we don't need it anymore. Otherwise, we'll return, well, not null. We want to return -1. and make sure this returns an int, and we'll change this to -1 to symbolize that there is none and that you should make this trainer lose. Okay, back in Game Runner, we can now use that to get our next monster indus and swap that monster in. So in this case, we have a monster that is fainted on the player side. We'll do trainer control. We'll do trainer controller dot get next usable monster index for the player, and then we'll do the same thing for the opponent. Just make sure you swap it to the opponent. Excellent. Okay, so now we have a number here. The number is either the index of the monster to put in or a -1. So if it's -1, we lose. Let's just change that comment. Handle loss. And then otherwise, it is a legal index like 0, 1, 2, 3, 4. We'll do trainer controller dot add trainer monster to battle using the player and the index that we got. Perfect, which is just a number and should work fine. It's mad because I don't have any content under the loss state there, but I'm going to handle that in a little bit. Now, if the opponent get next usable monster function returns -1, that means we have won the game, but otherwise it means they have to grab their next monster. Cool. I'm just going to put some prints here just because that's a easy enough way to show the win or loss. We have a screen we can put up later, but it'll take a sec to set up. So this will be fine just to make sure things work. Let's play it to see if it works. Okay, this is tedious. Let's fix some stuff up so that it's going to be a little faster. I'm just going to make sure smack does damage. We'll make it so it does less damage so that we can do a win here. So 30 damage. It looks like Reggie's dead and we get a win message in the console. Now let's give Reggie a lot more hit points and a better smack attack. Then we should lose and it should say loss in the console. So he kills our first guy. Even though it misses. Oh no, that's fine because we made it work on miss or hit, I suppose. Yeah, both. That's fine. A little confusing, but no, everything's okay. I'll just change it to hit just so we don't screw up later. I'm going to play again. Fight. Fast attack. Okay, Reggie takes us out. Okay, Steven doesn't have any moves, so we're stuck, and I haven't set up struggle for your own mons yet. So let's quickly give Steven a move. Not the one that will slow the things down by regenerating him, but we'll give him a fast attack. Okay, cool. He should be able to get pummeled by this powerful turtle now. Okay, fight. Okay, he's out. Fight. Okay, Steven's hanging on here. Come on. Okay, Steven. Steven has really good defense, maybe? Let's drop his defense down to 2. Something's funky with our math. You definitely have to tweak these things. Alright, let's play again. Fight. Okay, miss. Okay. Fight. Okay, Steven's down and we get a lost message. So everything is working more or less fine. Game needs some serious balance, but that's something we can do a lot later. Okay, so last thing we should do here is hook up some UI for this. So I already made a little UI panel for this. It should be in the project. And yeah, I didn't want to waste too much time messing with making UI for this for you. So I just gave it to you because that's kind of something you should learn separately from the data flow stuff that I am focusing on in this series. First, though, I'm going to make a new phase called Game Over. And I think how we know it's a game over is if we get to one of these states. Let's add it to our state machine, maybe. Yeah, here we are. So this is where we want to set the phase to game over. Once we have a -1 index for the player or the opponent. Okay, so now things will enter a game over phase, which we aren't really handling. And then if you look on the UI I've provided, there is a outcome panel here. So we want to hook that up. Great. So if you look at the script attached to the outcome panel, we already have a to-do here to connect up listeners to show and bind events. So easy enough. We go to events and we can find, oh, we actually already have an onGameOver signal here. In outcome panel, you can say events.onGameOver.connect, and it gets a bool for if you've won or not. So we can just call it based on that. And we just set it up to point to game over. Back in Game Runner, now we can emit that event. Easy. True and false will control if it's a win or a loss. We're not going to do anything else with these. So like if you want to add high scores or whatever, you can add that here too. Okay, I'm just going to remove this crap now because we don't need the print or anything. And I'll make sure that is emitting the correct Boolean. And let's just see what happens if we do a quick win here. You win. Okay, great. Big critical hit. Okay, so we have two buttons here, restart and quit. They don't do anything yet, so let's quickly hook them up. That should not take long. I'm just going to reset Salamander's speed again because it's way too high. And then in outcome panel, let's see, we have these restart and quit buttons. So we already have events we can call with them, I think. Well, actually, let's add a request quit and a request restart game signal. We'll add a signal for request restart game and a signal for request quit. Quit is a little different than request menu run, I think, because it won't log the taunting string. And we'll just let you quit the game. So quit press.connect, we'll do what we'll call func events.request quit.emit. Perfect. And then we'll have a similar one for restart pressed.connect. We'll put a lambda again, events request restart .emit. Perfect. Okay. Let's remove that to do because we have to done it. And then in Game Runner, let's just handle these. We will hook up events really quickly for them, and they should be simple enough. Request restart game.connect will connect what? Well, handle restart. We'll make a new function for that, and events.request quit. What do we want to do? Well, we'll make another function for that too. Okay, so down at the bottom here, somewhere, Well, we can use the same code for handle run for quit. So let's just do handle quit. And then we only need to grab the get tree.quit, actually. And that's fine. Let's connect handle quit right there so we don't have to duplicate that code, though it doesn't really matter. And then the other one we want to do is the restart. So func handle restart. Well, how are we going to do that? Well, I think we actually can just call setup model. And the way Godot is set up, we don't have to worry about removing stuff in memory specifically. Most of it, if you're using GDScript, is ref counted and will be disposed of if you're no longer referencing it. So setting up the model should just restart the game more or less. Cool, so knife dance, oh, we lost. Okay, we win and we click restart and it looks like it restarts things, but doesn't hide the menu. So that's something to fix. We lose, we can quit. Okay, so let's do a little work there. Well, well, we can set a listener here for when a new game state is created to hide this, because that's what's going to happen when restart is called. But we don't have to worry about it when we quit because everything's going to be disappeared. Okay, that looks like it's more or less working. Okay, and I think the last thing I want to do is clear the log so that it will empty out on restart. So we'll also listen for the same on new game state event in the log, and then we will try to erase stuff based on that. I'm messing up because clear is not clearing the right thing, so make sure you use the content container. Okay, if we restart, it clears the log, but you can still use your menu items during a lost state, so we should also make it so you cannot access the menu during a game over. Let's go to Game Runner and find where we have our menu handling. Find handle request menu fight. And okay. Well, remember when you click on something in the menu, it gives you something back from this. So we can really just short circuit this. So if we can check if we're in a game over state. It's called phase game over. So if current state or current phase, if current phase is not equal to phase .await input, we can return. We only want to allow menu choices during await input. So this will cover game over, and it will eventually cover when we add animations that are going to run asynchronously, and we don't want players to be able to start adding more inputs while an animation is playing. And we'll add that to all of the menu requests there. Great. So that way they can click on the menu, but nothing will happen if they are in a state where, oh, it's still working. Why is that? Okay, we have to fix this. And I think I know what's going on. So I'm just going to put a debugger here so that we can check what's going on. I'm going to play again, and we can hopefully hit a game over really quick. Okay, we lost. And if we click on Mon there, we get here. We have hit our debugging point, and we're checking if it's a wait input. So current phase, we can look. We can see that it is set to 0, which is a wait input right now, so it's not actually game over. And the reason for that is that we are setting it back to a wait input every time after a resolve round, and we should only do that if it's not a game over. So we'll just check here. We'll just do a check here to see if the current phase is not game over. In which case we will set it back to await input, otherwise it will stay game over. Okay, now let's try this. We play, we fight, and we should hopefully win or lose. Oh, we lose. Now we can't click on anything. We can still get the debugger, but that's okay because that's not a real thing. And then if we restart, hopefully, it'll let us click things again. It doesn't. Okay, why is that? I think we need to also add, in setup, we can remove the return because it doesn't need to return anything. And then we can set current phase to be await input. Perfect. And you know what? If we can't use that menu, we should probably just not show it. So let's hook up some signals to make sure that it is kept hidden when we are not using it. I'm going to go into the controls menu here, and then we can just hook up some listeners to check for when the game has ended and when it starts again, and we can hide and show the menu based on that. And hide is a function you can just put in there, same with show, and they are functions that belong to the node class that this inherits from. I need to connect it though, or else it's going to fail. Yep. Perfect. Okay, cool. Now let's see if this works. One last play here, and then I think we're okay for today. We lose. Didn't hide it. Why is that? Oh, I think we set something up wrong in battle menu. Oh, it thinks it's going to get it's giving it a Boolean, which it doesn't need for hide. So let's just make a quick intermediary function here, or we can use a lambda. Let's just use a lambda. Lambda can take in a underscore, which is the Boolean, but it doesn't matter. We'll just underscore it to signify we're not going to use it, and then we can run hide off that, and same with show. Actually, show doesn't need it, because on new game state created is not giving a Boolean. Cool. Signals, man, how do they work? Okay, we win, and our menu disappears. When we start, our menu is back, and we can use it. Okay, I think everything is now working, and we actually have a game flow, which you can use to actually play the game through, and it doesn't totally suck. So that's great. I think that's where we're going to leave it for now. Awesome. Thanks for watching. Next week, as promised, we'll be adding asynchronous animations and sound effects. They'll be configurable per move, and we'll introduce a brand new cool programming tactic to deal with that. Please like and subscribe for more. Please leave a comment and tell me your favorite integer, but no context for it. Just say a number, but it has to be an integer. And yeah, that's that. So I'm your dear departed hovering skull departing. Goodbye.